Welcome to Energize and Revitalize with Dr. Amy. I'm Dr. Amy Cooper Smith, a doctor prepared nurse practitioner. And this show is about empowering you to ask questions, explore different perspectives, and make informed decisions about your health. I'm very excited to introduce today's guest, Dr. Luke Bucci, clinical nutritionist, and you have a PhD in biomedical sciences. You're the chief scientific officer of Juvenon, and you're also the recipient of the Science and Innovation Icon Award for leadership and innovation in nutritional science and the dietary supplement industry. And that's just the beginning. So welcome and thank you so much for being here today.
Wow, thank you very much, Dr. Amy. It's a pleasure to be here, and I hope we can have a lot of fun and people will learn something too.
Yes. Well, in your work, you talk a lot about mitochondria and energy. So, and that's all over the supplement industry right now. Improve your mitochondria. So, what are mitochondria and why do we need to worry about them?
Oh boy, there are little powerhouses
Mm.
and our furnaces, and they're what actually generate the energy that our bodies need. They make the ATP, but we don't really know what they are. I didn't either when I was in like a little story here, because stories are good for people to understand things, and this makes you understand mitochondria better than anything you're seeing right now, because it's the truth. So as a grad student, I was forced to go listen to these experts in their field that were coming in every month to give their blah, blah, blah. So it's like, oh no, not another boring scientist. And this guy was all about mitochondria. And I'm so old now that he had black and white actual movies or film
Oh.
that's that you had to take with the tiny camera of mitochondria in a living cell. And
Mm.
this is like microscopic, of course. And I was like flabbergasted because you see the pictures of the cell in the textbook and you see a little sausage shaped mitochondria that's
Mhm.
kind of cut away and all these frilly things in it. And it's just stuck in the goo of the cell. No, these things were zooming around. They were zipping around
Wow.
like zip, zip. He had to slow, he turned the time, slowed it down so you could see them go. And that's what we don't realize. These little mitochondria have a minds of their own. They have their own DNA. They're some modification of an ancient bacteria before there were bacteria. And we just kind of became friends with the mitochondria. They give us energy, we feed them, they reproduce, everybody's happy. So that's something I think people don't know about. They have a mind of their own, but they are doing it for you. So, and
Yeah.
they give you 95% of your energy. That little extra energy they don't make is from your cells just burning sugar. And
Uh-huh.
that's, you can't live on that. It's not enough.
Right. So how do we feed our mitochondria?
Okay, they will eat anything that you eat. Your
Okay.
cells will make the little pieces that the mitochondria then suck up, and that's little pieces of fats and also sugars too. And it has to be broken down to tiny pieces, like the vinegar, acetic acid.
Mhm.
That's the major food that mitochondria eat because that's the major portion of what your food gets broken down into that gets turned into energy. The rest goes out in the waste. So they look for what are called acetyl groups. That's always attached with other things like carnitine, for
Mhm.
example. And that's then the mitochondria say, okay, open the doors, send in the goodies, and then they run it through their little frills inside to make ATP. And ATP is also very involved with NAD, which now is a big thing.
Yes.
So, geez, it's so misunderstood. Um, but NAD, in other words, you have a big process going on inside mitochondria to make this ATP. And it's kind of, it works out very nicely, actually, but it's like an assembly line. So you have things going on that make up all the precursors, and then all of a sudden ATP pops out, and that's what your cells use for energy. So here's how important ATP is. We all know those movies, we see the spy movies where the spy gets caught and he has to break his tooth and chew on the cyanide
Yeah.
capsule, he drops dead. Well, cyanide obliterates that chain reaction in mitochondria.
Okay.
And with that ATP, you drop dead, basically. So that's how important the mitochondria are.
Oh, wow. See, you mentioned earlier that the mitochondria prefer to eat the acetic acid. Is that where the apple cider vinegar craze came from so that we could directly feed them?
I think that's what was behind it, and they didn't even realize it.
Yeah. Do you think that works?
It can, but it's not good for your digestive tract
Oh,
because acetic acid is very acidic. And when you chop up fats and glucose and sugars, you get that two carbon unit that's attached to something else, like a coenzyme A, for example. We don't want to get into the weeds. So, in other words, it's
mhm.
not acetic acid itself that gets in your mitochondria, it's that two carbon thing.
Okay. So it's
So,
a nice
that's the
idea,
difference.
but maybe a little misguided.
Um, it also is, believe it or not, even though it's acidic foods actually will make your body generate antacids,
Hmm.
so which are alkalinizers. So it actually alkalinizes your body pH. So if
Okay.
if your body's attacked, it mounts a defense, and that's so actually some acetic acid is actually good.
Right. So
Um,
like cancer
if you
preventing, that sort of thing.
yeah, I got my uh, PhD in the world's largest cancer hospital. They don't like any of us mentioning where we came from if we're not there anymore.
Ah,
But you know which one that is. It's in Houston, Texas. That's as far as I'll go. Learned a ton. And
right.
obviously cancer is everywhere. I've talked to a lot of people with it. And it's again, your body going crazy. So alkalinizing is good because cancer cells have their energy production is messed up and they're grabbing everything before anybody else is the short way to say it.
Hmm.
And that means they're out of control. So that means they're generating a lot of acid. So if you use things that are alkalinizing, that sort of slows it down.
Mm,
Whether I mean, I'm not going to say you can cure cancer with it. No,
right.
but it makes you healthier in the meantime, so you can do whatever else you need to do.
Right. And that's important. So the mitochondria will eat the byproducts of our fats and sugars. Are there certain foods that work better or, have better energy production?
Um, yes, and there are. I think the carbohydrates are the best source
Mm,
because the sugars get chopped up faster. They're smaller. They unlike fats. Most fats are not soluble in water. You have to
mm,
um, get those triglycerides broken down into those little acetyl groups as fast as you can. And so there's always something stuck on the pieces of fat so they can go into your watery bloodstream and then into
mm.
your watery cells into your watery
Yeah.
mitochondria. So fat and oil don't mean, yeah, fat, oil and water don't mix.
Hmm.
So it takes more energy, more trouble to get the same energy out of fats. I mean, yeah, per gram that you eat, it's 9 calories per gram, and carbs and proteins turn into the same thing sugar do and give off ammonia, and that's 4 calories per gram. So everything. Oh yeah, fat's the most concentrated form of energy, but how much energy is your body using to actually use it? So glucose and carbs, starch is easily digested. Your liver stores its own starch called glycogen, so it
Hmm.
can keep your blood sugar up when you need it. This is very important for exercising, by the way,
Yes.
so as everyone should know by now. So in other words, yeah, I think it's the carbs. Protein, if you can live in protein, but you're throwing off a lot of ammonia you have to get rid of. And that can, you have to be careful with too much protein because then the ammonia gets to be too alkalinizing and that becomes toxic. What happens when you have a ball of ammonia? It's deadly. So
Yeah.
yeah,
Well,
so
that's interesting
carbs.
because right now protein is very popular, especially when we're talking about muscle preservation and, and weight control. So do you think that too much, as you said, can be harmful?
Um, I do, but I think it's very hard for people to actually get that far
Good.
if they're only eating just protein. And a lot of keto diets tend to
Hmm.
be close to that. Then that's where you get on the acidic side, believe it or not, because of all the waste products and trying to dispose of all this ammonia, which is alkaline. And I think that the more protein is actually a good idea because it helps you maintain muscle mass even if you don't exercise. Now,
Mm.
my career at Weider Nutrition was all about bodybuilding and muscles, so I know way too much about that. And another little story: I was a pencil neck geek when I went there,
Oh.
and they took one look at me and said, "We're throwing you in the gym, Bucci." It's like, uh-oh. I, they made me work out, a weight workout. I literally was so sore that it hurt every time I took a breath. I mean,
Oh,
ow,
yes.
ow. So I was just sore for days, and I thought, okay, that's not right. You're out of shape. Go with the program, and gained was that 32 pounds and lost body fat percent. So
Yes.
it's like, hey, if I shave, I could be a bodybuilder, and I don't have the time for that, and that's a mess. So anyway, yeah, protein is can be good, but you need the energy to go with it, and I think different people also, some are good at digesting fat and breaking down fat, and
Yeah.
some aren't. Uh, Different kinds of fat, we can go all crazy with that, but really, I think if you're using all kinds of carbs, not just sugars,
Right.
starches, and then fibers, which
Yes.
and that enters into the gut microbiome, which now we realize how important your gut is. It's not something you're trying to get rid of, it's something you're trying to feed properly.
Yes. So, where does the supplement industry come into keeping the microbiome healthy?
I think the supplement industry is well set up to do it correctly and do it very precision nutritionally, if
Yeah.
I can say that. Now we know that our gut microbiome is our biggest organ.
Mm.
Yeah, bigger than
Not the
it's just
skin.
not the skin. I mean, skin is if you don't count the inside of your gut
Yeah. Well,
contents,
all those
but it's
folds.
pushing it.
Yeah.
Yeah, because skin is only skin thin or thick.
Mm.
So,
Right.
but you have pounds of bugs in your gut.
Yeah.
Don't look, because then you'd have to, well, never mind.
Yeah.
I won't say it in public. But that's the point. And what you eat definitely makes a huge impact on
Hmm.
the gut microbiome you have. And we always thought fiber's good because it makes you regular. Well, it's really good because it feeds your bacteria preferentially because you can't digest it, so they can. And fiber is making good gut bacteria healthier and giving them fed and not the bad ones. So when you lose out on feeding your good gut microbes, then you get the bad ones. And that I think is really a detriment to long term health and longevity, even. So fiber is good.
Yes.
I think that the fibers kind of got lost in the shuffle because now we have ways to take care of your gut microbiome. And I've always had to use and sell and understand probiotics
Yes.
in my career. And then prebiotics came, which are actually little fibers that we can't digest, but they can. So, and then there's this fiber that we can't that we like chew on, and it goes through us. But really, the gut bacteria, and then so then there was prebiotics. Okay, that'll feed your
Yes.
good gut bacteria pretty well. You have to eat pretty good amounts. It's not easy to do with regular diets. So that
So,
okay,
is this like kombucha and things like that?
yes, they're really more of a prebiotic, but they're also a probiotic, depending on
Okay.
how fizzy they get, because sometimes they're live. And the other, so you have three things: probiotics, live germs, gut
Yeah.
bacteria, fungi, like kombucha, whatever. Then you have postbiotics, which are
Oh,
dead probiotics.
okay.
Then the prebiotics are your fibers and other things. So the basically a probiotic I've learned over the years with trying to figure out how to make probiotics work better.
Mm.
Probiotics turn into postbiotics immediately. That's what they are. So I'm glad to see that postbiotics, which have been drugs in Europe and around the world,
Oh,
saving millions of people from dying of diarrhea,
yeah.
that and they're using it by using a heat-killed lactobacillus or whatever. Bacilluses, all those things. Um, I think that so in other words, I think probiotics, the live bacteria, they're difficult to keep it stable.
Right.
And I worked for companies that sold the spore formers, which are immortal. You can't kill them. And
Scary.
that's fine, but yeah, it's like okay, and they're a little harsh for some people, but they're still good probiotics.
Yeah.
But they're like a postbiotic that's alive. But what's even better is, I think, these prebiotics, the
Oh.
fibers, and the new prebiotic. There's other prebiotics that aren't fiber, but the biggest one that we're hearing about now is butyrate.
Mm, yeah.
And that's something that I got exposed to in the 80s for cancer therapies.
Okay.
It obviously didn't work really well, but and it's stinky, nasty, acidic. It's butyric acid. It's very acidic.
Oh,
You had to have it bound to calcium, magnesium, and I was with a company that was trying to make it for other people that would sell it. And oh my goodness, butyrate is the essence of bad gas.
oh.
It's like rotten butter smell magnified.
Hmm.
Seriously.
So if
So
somebody
now,
were to utilize that, they would be a little unpleasant to be around.
actually, no, that's been the
Okay.
breakthrough lately. And we didn't have this 40 years ago, 35 years ago. Now we have butyrate salts and butyrate compounds that stay intact, and they don't stink, they don't smell, and they get into your gut where the bacteria just love them. That's why fiber is good for your gut bacteria, because they convert the fiber, which is mostly carbon, into butyrates,
Huh.
and they eat it, and
Wonderful.
that makes your whole gut membrane work. You keep out bad germs and bad compounds, so your liver is happier and doesn't get as poisoned and thus poisoning you. So in other words, it all starts in the gut, like everybody
All
is
starts in the
correct.
gut. So we're
And
going to
that's
pause.
it.
We're going to pause for a break from our sponsor. You're listening to Energize and Revitalize with Dr. Amy. Don't go anywhere. We'll be right back. Okay. Welcome back to Energize and Revitalize with Dr. Amy. I'm Dr. Amy Cooper Smith, and my guest today is Dr. Luke Bucci. Before the break, we were talking about the mitochondria, the gut health, the importance of the microbiome. And you mentioned that prebiotics were probably the best way to go at this time. So, what are some easy ways people can get prebiotics?
Again, the first best way to get the prebiotics is fiber. And
Fiber.
any kind of
Great.
fiber works, but you have to be careful with your GI tolerability,
Mm,
and you can't just take shovelfuls of gosh, fiber supplements, because you will
right.
launch yourself to the moon, and then you go, I'll never do this again. So you need to eat. It's better just to eat whole foods,
Right.
plant
Broccoli.
foods.
Yeah.
Meat and animal products are not don't have fiber. They don't have fiber.
Right.
No, so you have to eat plant foods, and
Yes.
raw is better. So in other words, we just do what you're supposed to do with your diet, which is a
Yes. Eat
big
real food.
big thing. Yeah, eat real
Correct.
food. Simple, simple.
Yes.
And
So,
then the new one is the butyrates themselves
yes.
that your good gut bacteria make. Nice thing about butyrate is the bad gut bacteria get killed off by it. So that's what your good gut bacteria use as an antibiotic to kill off its competitors,
Mm,
the so-called bad gut bugs. I mean, it's a
nice.
little more complicated than that, but your butyrate is also an energy source for the cells in your large intestine. It
Mm,
eats, because it's constantly being secreted, your colonocytes eat butyric acid, and they make energy out of it, because that's what happens with a lot of fat. Some of it gets converted to butyrates and it goes straight to your mitochondria, and butyrates just two of your acetyl groups that go into the mitochondria the most. So in other words, it's your body knows what to do with it once it's inside your system and is not turned into butyric acid itself. Something's always stuck on it.
wow. So earlier in our discussion, you mentioned NAD, and I wanted to come back to that because that is very popular right
Mm,
now. There are
mm,
NAD supplements, NAD injections. So tell me
mm.
about your thoughts about NAD and what we're doing.
It's crazy. It's gone crazy, I should
Yeah.
say. NAD is made in your mitochondria, or is made for
Okay.
your mitochondria. Your mitochondria really makes it. It makes it from vitamin B3, which is niacin or niacinamide and a few other forms. So that's why it's essential. If you don't have enough, you get pellagra and your skin starts to fall apart, etc. Which nobody has that problem much anymore in countries that enrich flour and eat a plant-based food diet. And meat is also high in it too because of all its mitochondria. So in other
Okay.
words, but the NAD is what handles that those acetyl groups that come into the mitochondria we talked about. Well, that gets torn up into water and carbon dioxide, and it's a multi-step process. A lot of big enzymes that have moving parts, literally like little grabbers and tearing things up. It's amazing the detail they have on this now. And NAD runs those enzymes,
Hmm.
especially the key ones. And that means it's an energy producing coenzyme. And it's made from vitamin B3 or any kind of niacin or niacinamide. NAD, in fact, is nicotinamide adenosine dihydrogenide. Anyway,
Yep.
it's basically B3 with the base, the A in your DNA and RNA,
Okay.
adenosine, and then that has other things attached to it, and it's two of them stuck together. So that can hold a little electrical charge, which is taken from your food to recharge ADP into ATP, and then that gets kicked out, and that's what your cells take that last P off, the phosphate, and that pops that energy back out on your enzymes or wherever you want it. So that's how we live. And then cyanide completely kills the mitochondria from making ATP, so you don't have any more, and you need ATP 24/7 all the
Yes.
time, every second.
So we're doing a lot of supplementation of
Mhm.
that. So are we not getting enough from our diet, or are we just trying to get more because we want
We're
it?
trying to, I think we're wrong-headed in the industry. I have
Okay.
to hope I don't get assassinated, and I'm saying that so I won't get assassinated. But I've seen the rise of NR, which is niacinamide riboside, and NMN, which is a very minor, nicotinamide mononucleotide. These are salvage pathways, backup systems. They're in very tiny amounts in your cells, so that's there. What you're doing by flooding your cells with this is you're shoving so much that you get a little more NAD in your mitochondria,
Okay.
but you have a tremendous amount of waste. So all these companies are bragging about, we got our niacinamide or NAD boosted in the blood 5 million%, whatever. Whoa, wait a minute. That's on the way out. It's not in your cells in the mitochondria where you bloody need them.
Hmm.
And that's the problem, because as the medical use of high dose niacin, the N of NAD, for lowering cholesterol, it worked,
Right.
but it was nasty. You
Yeah.
flushed and all that kind of stuff, and it caused liver problems, liver damage. It was toxic, and they found it didn't really help save your arteries from going nuts.
Mm.
So they did not realize that they were it when your body gets too much in
Yep.
niacin, it turns it into two compounds called 2-PY and 4-PY. I can't pronounce them. You can look it up. But 4-PY is cardiotoxic. That's what
Mm.
made niacin overdoses deadly.
Hmm.
And it slowly eats up your blood vessels, and it pickles your liver. And that is
Hmm.
exactly what has been shown by the brave scientists that looked at it. And you don't see the people that sell these things looking at 4-PY levels in their
Right.
studies. I mean, they
So
can
do
get
you
some
think
results.
the way we're giving it to people is actually affecting the heart and the liver negatively.
It will. But
Too
they're
much,
not
too
look.
long?
Yes, and it
Okay.
doesn't take, and they're giving, in other words, they're getting into the same milligrams per day that niacin was that
Yeah.
was toxic. So they're given the
Okay.
same rough amount.
Mm.
They're getting close to the same amount of N niacin that with the different NRMNs and other things. Even niacinamide, which is supposed to be not that toxic, it has the same problem too if you start going 3 or 4 grams a day. So in
Mm-hmm.
other words, too much N
Yeah.
niacin is simply the liver just turns it into these things to, and they go out in the bloodstream to go out in your urine.
Yeah. I feel like we should know this because we know about you know, B3 and its uses medically. Like, so is
Oh
this?
gosh, yeah. I was all in on these things. I thought we need to do this for Juvenon, for example, and
Yeah.
I started looking into it and I always look at safety, which a lot of people forget to
Yes.
do until they are selling it. And because I knew about niacin and niacinamide and that from being my age, and those were drugs. And they were like, okay, why aren't these nutrients working as drugs? Oh, they're toxic? Wait a minute, how that happened? They're nutrients, they can't be toxic.
Hmm.
Well, they are. So I thought, okay, let me look at NRNMN and oh, look at the literature, and you go, this little voice in the wilderness saying, wait, 4-PY, it's cardiotoxic, you're going to kill people. And profits over
Yeah.
safety.
Are
I don't
there
know what else
safe
to say.
doses of these things if maybe we don't overdo it?
I don't think so because these things are very minor
Yeah.
parts of the pathway from niacin itself that we get out of our foods and niacinamide into NAD. It's a multi-step process, and you have lots of enzyme steps to make it in the mitochondria. So these are in very low quantities in our cells. And it's only
Mm,
recently that they've been made in mass quantities. And the only way they have good clinical results is to give the same high doses that niacinamide and niacin themselves had to reach.
right.
And I think they're safer than niacin and about the same as niacinamide. But long term, I think, wait for it.
Yeah.
I
Yes.
hate to see what's going to happen. So what I decided to do was, okay, fortunately, I know a lot of suppliers, and there's some good ones, and they jumped on this too and figured out, okay, if we can mix this and that and this and that and then give it to people, we have shown clinically that we can boost the NAD inside their cells, the white blood cells of the blood, and we don't boost it in the 4-PY and stuff in the blood. So
Hmm.
it's like, hey, and there's no N at all in the products.
So the body just makes is more efficient and makes more of the
You're,
product.
yes, what you're doing is you're tickling the body to make more the way it normally does, so
Mm,
its pathways for disposal are not swamped and overloaded.
right.
So you're within normal limits, and it also does good things for your white blood cells. It makes them meaner if they need to be.
Yeah.
It makes them work better, and it also makes the enzymes that run on NAD in your nucleus, in your brain of your cell, it makes them a little more functional too. So it's basically doing what NAD is supposed to be doing when we take it orally, but it's doing it the way the body likes it. So
Nice.
there's other ways to make NAD cooperate with that using anything that has any NA in it.
Yeah. We'll definitely need to research that some more. We're almost out of time. So how can our listeners learn more about you and connect?
Well, I'm the Chief Scientific Officer at Juvenon, and we have a website at www.juvenon.com, and that's Juvenon. We have a line of products that are mostly for 40 plus people, and we've been around a long time. Founded by Dr. Bruce Ames of the Ames test, and people go, "What's the Ames test?" That he developed that test using bacteria to you feed it a compound, and if its DNA gets messed up, it's a mutagen, which means it's going to be more likely a carcinogen or cancer forming. So it's the Ames test is used worldwide,
Wow.
and checking out sewage is checking out new compounds. If you have a new compound, you better do the Ames test because if it's positive, it's not going to go. It's And he had other Nobel Prize winners, and they said, um, because they got into, believe it or not, NAD right away, and they
Ah.
said using NAD itself is stupid because they knew what it was like, because they used it in their labs like I did, and it's not stable by itself. So you need to keep making it. So they developed acetyl-L-carnitine and lipoic acid, and that's what started Juvenon. And
Ah,
guess what? That feeds mitochondria. So here
nice.
we are, back to mitochondria again.
And it all comes back to
Amazing.
mitochondria. Nice. Well, thank you again. I really enjoyed our talk. I learned a lot.
I'm very happy to talk all day, but I think people would fall asleep.
We'll just have to do this again sometime.
I'm ready when you are, Amy. But thank you very much for having me. I really appreciate the chance to get these nuggets that nobody knows about
Yes.
um, into the world, because we need to know.
Yes. Thanks again. And thanks to our listeners for tuning in to Energize and Revitalize with Dr. Amy. Do you have insights from this show? Send me an email at radiantpodcast2025@gmail.com. I'll be back next Saturday morning at 7:30 with more expert insights and practical strategies to help you live a radiant and healthy life. Until then, stay curious, stay informed, and keep energizing your life.